is right. It's only the half of the parabola, right? And so he says it restricts on domain because it's a real life problem. You can't have a negative number of feet. Now, Kelvin, what did you put as the domain then? You put what? 0 what? 0 to infinity. He put the domain as 0 to infinity. How did you write that? Okay, you put brackets, 0, infinity. Could you do that? Or what's another way you could write it? You can actually just write it like that, okay? So that's the domain, right? Now, let's... Listen, you guys, we got to get through this. Okay, I'm going to give you the assignment whether we get through it or not. And if you know how to do it, you know how to do it. If you don't, you don't. So you got to listen so we know what we're doing. This is really important. When we start talking about real life problems, you got to start thinking about domain a little bit different. It can't be all the real numbers because the function, what is the function? What is the function we started off with? X squared, right? So the function we started off with f of x equals x squared. And the way that Jaden graphed it was correct. We have both sides of the graph right here, right? But then Kelvin realized that, hey, this is a real life problem. You can't have negative feet, so the domain can only be x is greater than 0, so we had to erase the left side of that. What about the range? What can the range be? Say that again. Okay. Yeah, it has. Good. Why does it have to be greater than 0? Because you can't have a negative amount of what? Ounces in ink. So the range. How did you write it, Caitlin? We put it in brackets like this one. 0 to infinity. Or could I put y is greater than or equal to 0? Yeah, I could do it that way too. So either way, Kelvin. Well, you could not have a sign, right? So it could be 0 commas. It could be 0 comma 0. 0 could be included in that domain technically. Yeah, exactly. So it's never going to get lower, so it's always going to be greater than that anyway. That's what you're saying about the range. Yeah, you're right. Okay. Okay, now let's talk about number 2. How many of you guys are done with number 2? Okay. I want to see the table of values someone got on number 2. So let's look at the table of values right here. Okay. Let's see what someone put in for x and y. Okay. So someone come up and do it. Who's got it? Okay, Kyle, come up and write it down. This is problem number 2. X and y. So wait, let's use the top 2 row, the top of each row, and label what they stand for. What does that first one stand for? Does it stand for length of the side? Well, I don't want to put x and y because we need to talk about what did you get your first column of numbers? What did you get? Okay, what was that on the first one? Ink. So is it going to be ink again on the second one? Yep. So ink. And what does the y column represent? Length of the sides in feet, right? Ink in ounces, right? And length in feet. Huh? Now, you guys, this is critical to understanding inverses. You need to understand by what Kyle's writing down here. What did he do to find this? It says find the inverse. He switched the x and y, didn't he? So does that include switching what they stand for? So is ink now your independent variable? Yeah. Okay. So let's put a generic thing down there. If ink is x, what is length in feet? No, ink is x. Ink is x. So what is length in feet? X to the 1/2 power. What's another way of writing that? Square root of x. Good. Square root of x. Because if you look at all those problems on the left, we took the square root of them to get the one on the right. Is that correct? Okay, who can come up and draw the graph of that one for us? By the way, could we list some more points? We could list some more points, couldn't we? Okay. In fact, well, let's do this. Okay, I'm going to put this right here. Well, we can actually make that go a little bit lower because we only need a certain part of that, right? Okay, who can come graph that for us? Who's got a graph? Jaden, you already did one. I'm going to see if someone else has one right here. Okay, Hannah will do it. Hannah, you going to do that? Thank you. What do you guys think? Everybody think it's different? Okay. Branson, go fix it if you think it's different. So you're saying it looks like that. Did you actually graph the points on there? I mean, yeah, that's kind of what it looks like. It would be better to put the points on there, but he's right. So 0, 0 is on there, right? Let's put 1. 1. If we put 1 here, square root of 1 is 1, right? So 1, 1. 2 is not a very good one to use because what's the square root of 2? It's a decimal, right? What's the next square root? 4, right? Perfect square. The square root of 4 is 2. So we're going to go out 1, 2, 3, 4, and up 2. And then 9 is the next perfect square. Over 9 and up, the square root of 9 is 3. So it's going to look like that. But he had the same thing. Now, what is the domain of this one? What's the domain of this one? Same as the last one. This one only exists greater than 0. And the range as well only exists greater than 0. Because it's a real life problem, right? Okay. Now, question 3. Explain in words what the inverse function represents. Who can explain in words what the... just tell us a few things. We know all these things. We learned about them last time. What are some of the things the inverse function represents? Switching what? Switching the independent and dependent variables. Switching the variables, right? Switching x and y. Okay, what else does it mean? It's another way to explain what? The information. I like that. Did you guys hear what Christian said? You guys, some of you asked me, what good is an inverse? Who asked that question a little bit ago? Okay, what good is an inverse? Well, an inverse is a different way of explaining something. If you have two quantities that you've compared and you're using an equation to compare them, you can explain it in a different way by finding the inverse. And just like that problem we did last time, that task, where we had that one where the person clocked themselves by miles per hour, and the other one's how much time it took them to do 1 mile. That's two different ways of explaining how fast they move, right? And it's just a different way of explaining things. Branson. Well, it's not quite like that, but Jacoy. Were you raising your hand? Okay. All right, so we're going to go on to, and there's one other thing I want to talk about. What are inverses always a reflection over? The line y equals x. Okay, do that. Okay, turn this over to your task. Turn your task over to the next page. I am going to demonstrate, well, actually, I think you guys can do this. I want everybody to do number 4, and then we're going to have a discussion on it. So I'm going to give you a few minutes. Go. So yeah, you guys, we have to erase, on the blue one, we have to erase this half so that when we flip it over the line y equals x, it doesn't need this part right here. See that? Yes. Otherwise, the inverse will not be a function. So, what did we learn from that, you guys? Yeah. Now, who solved this equation? I want someone to come up and solve it. Okay. I want to find the vertex. Will you do it, Brendan? Well, it's all right. We learn from it. When you guys don't do things right, it's okay because we learn from it because you're not the only one making the mistake. So just do it. Show us what you got. Well, show us the steps to do it. I want you to go through the whole problem. Put the original problem. Well, I think it's -1. Is the question -1? Now, hey, the whole x plus 1 is under the square root. Because you can't take, you can't take the square root of 1 when it's being added. You can only do it when it's being times. Okay, good. Now write it in, no, that's, oh, we forgot to switch x and y, didn't we? Okay, wait, just don't erase it, just switch it now. To down at the bottom. Well, yeah, just rewrite it down there, and just leave that as a y. Re-erase that, put that as a y. And just rewrite it right underneath here. Square root of x plus 1 equals y. Now use inverse notation. F inverse of x. Remember the little -1 thingy? Of x equals square root of x plus 1. Yeah. Okay, I want everybody's eyes right here. Thank you, Brendan. Okay, look, you guys, Brendan did this in a little bit different order. But he had y equals x squared minus 1. He replaced f of x with y. And he solved for x. And then when he got down here, because he added 1, and then he took the square root of both sides. Then when he got down here, he switched x and y at the last. That's fine, too. You can do that. And so he had y equals the square root of x plus 1. And I had him write it in inverse notation. F inverse of x equals the square root of x plus 1. And that's the one that gave you this graph right here. Okay? That's the one that gave you that graph right there. So notice what kind of function it is. What kind of function do you think we call that? We call it a square root function. How do you get a square root function? By finding an inverse of what kind of function? A quadratic. I want everybody to write this in your notes. Everybody take out your notes. Write this in your notes. To get a square root function, you take the inverse of a quadratic function. To get a square root function, you take the inverse of a quadratic function. To get a square root function, you take an inverse of a square root function. And you have to restrict the domain, don't you? To get a square root function, you take the inverse of a quadratic function. Sorry. To get a square root function, you take the inverse of a quadratic function. And you have to restrict the domain to do that. Because if you don't restrict the domain, you're going to get the bottom part of this thing right here, and it's not going to be a function, right?
What's the scariest thing that you have?
I'll tell you later, not right now. Okay? All right. Okay. We got that. Okay, you guys, number 5. I'm going to do number 5 with you right now. Okay? How many of you have done it already? Oh, actually, that's a line. You guys can do that one easy. I'm going to give you 1 minute to finish it. Go. If you're not done, you should be done in 1 minute. Okay, this is number 6. F of x equals x plus 3 squared, right? What kind of function is this, everybody? Okay, this is a quadratic. I want all eyes right here. Okay? Step 1. What's step 1? No, step 1. Change fx to y. Okay, that's step 1. Eves, what's step 2? Switch the x and the y. Kayla, what's the next step? How do I do that on this one? Think about it. Probably going to take the square root. That's going to leave the square root of x equals what? Y plus 3. Because remember, y plus 3 squared, taking the square root of y plus 3 squared undoes the square, right? I did. Okay, and minus 3. And I get y equals the square root of x, subtract 3. Now notice, this time, you guys, this time, the negative 3 is not inside the square root. Because over here, it was inside the parentheses, unlike the other problem we did. That is a critical thing to know. You guys understand that? What's the last step? Use inverse notation. F inverse of x equals the square root of x plus 3. And then we graph them. Now, I can tell you right now, I know that to graph x plus 3 squared, all it does is shift a parabola to the left 3 units. 1, 2, 3. Remember, it's vertex form. Remember how we learned the vertex form already? Yeah. And so we go over 1 and up 1, over 2 and up 1, 2, 3, 4, and over 3 and up 9. And why? How do I get 9? Because I know this goes up to 10 on mine. Okay. And over here, I could graph left 1 and up 1 and left 2 and up 2, but what's the problem with that? I have to restrict the domain because this is a quadratic. And I know that when it inverses, that it would not be. See, really, technically, when I took the square root of both sides, this should have been plus or minus. If I wasn't looking for the inverse, I'd take the plus and minus, and then I would have 2 functions over here. But since I'm looking for an inverse, I don't. So this point right here is negative 3, comma 0. If I flip those around, it's 0, comma negative 3. So there's my next point right there, right? This point is negative 2, comma 1. Negative 2, comma 1. To find the inverse, I do 1, comma negative 2. Okay, this point right here is negative 1, comma 4. Negative 1, comma 4. I do 4, 1, 2, 3, 4, comma negative 1. This point right up here is 0, comma 9. I'm going to do 9, comma 0. There is my function. Are they reflections over this line y equals x right here? Do they reflect over that line? Perfectly, okay? That's what we are doing. Okay, now the very last one, number 7, is a cubic function. Okay? We have never graphed a cubic function in this class this year. I know that these two did in their other class because she teaches it at the first of the year. But what we have there, in that case, is we have 0, comma 0, we have 1, comma 1, and negative 1, comma negative 1. And we have 2, comma 8, and negative 2, comma negative 8. It's going to look like this. It's a function that looks like that. Now that one we don't have to restrict. When you find the graph of this one, it's going to look kind of like this.
That one looks cool too.
Okay? And it's a reflection of the line y equals x. And so if you take y equals x cubed, what are you going to do to both sides of this? After you switch x and y to find the inverse, what are you going to do to both sides of this? You're going to take the cube root, right? And so you're going to get y equals the cube root of x, which if I change to inverse notation, is f of x equals the cube root of x. There's your inverse. We graphed it. The domain and range are all real numbers for this one, aren't they? Because the domain is all real numbers for both of them, and the range is all real numbers for both of them. Okay, we are ready to move on to the assignment. I'm going to do a few of these with you. On your assignment, it asks you to name discrete, continuous, or discontinuous functions. Okay, it asks you to name these three things. Let me tell you what each one of these are, okay? A discrete function has points, just points. So if you had an xy, it would just be something like this. Okay? That's a discrete function. Okay? A continuous function is a function you can, a function that can be traced. Without lifting your pencil. And a discontinuous function, it has continuous parts. It has continuous parts, but you have to lift your pencil. Okay, so what I want you to do really quickly, problems 1 through 6. I want you to go through them and tell which ones are discrete, continuous, and discontinuous. I'm going to give you 1 minute. Go, in your groups. Thomas, put these away so I don't see them again, okay? Thank you. Increasing means as you go left to right, you go up. Okay? Decreasing means this. Decreasing means left to right goes down, right? Constant means left to right, not linear, because all of them are linear, is horizontal. In other words, it stays the same number the whole time, right? Okay? So it means it stays horizontal. So now I want you guys to go all through all 6 problems. And let me just talk about number 1. Let's do number 1 and 2 together. What's number 1? Okay, it's continuous and increasing. So you should have increasing on there. What about number 2? Well, it's increasing. Oh, no, it's decreasing. Then it's increasing. Then it's decreasing. Say that again. Thomas, say that again. Okay, it's decreasing, -10 to 0. Well, yes, because it does include them. Yep, you're right. So it increases from -10 to 0. It's in the brackets because it includes those points. What about the next one? Increasing from where to where? 0 to 3. It's increasing from 0. Oh, but this time it's not in brackets. Why not? Because it doesn't include 0. It has holes there, right? In the graph. Do you guys see how it has holes? Then what is it doing? Decreasing from where to where? 3 to 10, it decreases. 3, 10. Those are in brackets because it does include those points. Does that make sense how you do that, you guys? Now, on number 3, you guys got to determine, like on the very first one, it decreases from where to where? On number 3, where does it decrease from, you guys? -4 to -2. But are you going to include -2 on that segment or the next segment? That's what you have to decide. It's up to you. You can do it however you want that way. But don't include it in both of them, but include it in at least one of them. Okay? So like on number 3, you guys, on number 3, it's decreasing. I might do something like this. It's decreasing from -4 to -2. And included on that one, which means on that part where it's increasing, I can't include -2, so I put a parenthesis because that means it doesn't include -2 to 0, and I might include it at 0. But where it starts going constant, now I have constant. It goes constant from 0, but I don't include 0, so I put a parenthesis because I already included it over here till 5, right? And you can include 5 because it includes that point right there. Does that make sense? Okay, so we did the first 3. You guys can finish those next ones. Now, guys, go back. The other thing you have to do is tell the domain and range of each of these. Now, I want to talk about number 2. Number 2, domain and range. Everybody go to number 2, domain and range. Okay, number 2, what's the domain go from? From where to where? It goes from -10 to +10. -10 to +10. Yeah, it's discontinuous in between there because you have to jump up, but it doesn't leave any gaps going left to right. You include every single number left to right. Okay, turn it over. Oh, that'll work. Okay, so that's that. What's the range of this one, though? What's the range of this one? That was domain, right? What's the range? What's the range of number 2? -4 to 7, did you say? It includes every point there, right? So it includes -4 to +7, so that's the range. It goes from up, down to up, yes. Oh yeah, it doesn't include 7, you're right. Okay, sorry. Okay, there's a parenthesis there because it doesn't include that point, okay? Any questions on those problems? Okay, everybody turn to problem 7, just so I can explain some stuff to you right here. Number 7 is inverse functions. They're going to be square root functions because you're going to take inverses of x squared, functions of quadratic functions. So just keep that in mind when you do that. I'm not going to say anything else about that page. Turn it over to page 33. Problem 11 through 16. 11 through 16. 11 through 16, you have to solve for a certain variable. Let me give you an example of one. Let me just do number 12 because the bell's about ready to ring. Right here, if I have a equals pi r squared, and it says to solve for r, I'm going to start off by dividing by pi. So I get a over pi equals r squared because pi's cancel out there. I'm going to take the square root of both sides, and so it's going to be r equals plus or minus the square root of a over pi. So that's what you guys are doing today, is just solving for a variable. Okay? Now, what's due next time? 4-5 is due next time. 4-6 I'll answer questions on. Okay, see you guys.